Taking a look at rational expressions and functions 4.2. So the first, just dealing with some regular fractions, right, to kind of get us in thinking through how we're going to deal with these rational expressions. They're just more complex fractions, but we're doing the same type of stuff with them. So the first one, 1/2 plus 1/3. So what do we have to do first? Well, we have to get those common denominators, right? So I can times this side by 3 and this side by 2. Because whatever we do to the bottom, we have to do to the top. In other words, the only reason we can change this fraction is by multiplying it by 1. Because multiplying it by 1 doesn't do anything. The difference is we change 1 to something that's going to help us, like 2/2, which is still 1. But when we multiply that, we get 2/6, which when we multiply this one by 3/3, which is also 1, we get 3/6. Now with that common denominator, we just add the tops, and we get 5/6. Okay, same with number 2. How do we get 5 and 3 to be the same? Well, we times the right side by 5, giving us 5/15, times the left side by 3, giving us 12/15. Subtract them, 12 minus 5 gives us 7/15. And the last one, they can both become 10, so we times this side by 2, giving us 4/10, plus times this side by 5, and we get 35/10, so we end up with 39/10, which cannot be reduced either. So, if we skip ahead to number 7, what's the process for adding and subtracting two fractions? Well, we find common denominators, right? Common denoms. And then add or subtract the top numbers, the numerators, right? Keeping the denominator the same. Something like that. Alright, now if we look at these multiplying. Multiplying is nice because we just multiply across tops and bottoms. So 1 times 1 is 1, 2 times 3 is 6. A look at number 6 is also multiplication. We can just multiply across like this and get 6/40, which we would reduce to 3/20. Or we can realize that multiplying kind of means that we multiply top and bottom. Well, 8 is like 4 times 2, so 2 on top and bottom cancel out, giving us 3/20. Okay. So looking at 8, how do we multiply two fractions? Well, you multiply the numerators and denominators with each other, right? Something like that. Just multiply across there. Now that last one, division. Division, we have to do one extra step, don't we? We can't divide fractions, but if we think about it, dividing by 2 is the same as multiplying by 1/2. So that reciprocal idea is we multiply the reciprocal and then we multiply across. So we get 5/12. So number 9, how do we divide? Well, we instead multiply by reciprocal, and then we do that. Okay, so looking at those, that's kind of how we take it. So we're going to do that same thing when we get to these type of problems. Okay, we're going to do that same process. So let's talk about those ones right now. We'll jump back to these ones and talk about the simplifying. But I wanted to kind of jump straight into this. So multiplication here, we're going to multiply across top and across the bottom. So 8 times 3 gives us 24, x squared, y squared. Now 9 times 2 gives us 18, y, x to the 5th. So now we look to simplify. Well, 18 is like 3 times 6, 24 is like 4 times 6, x squared is 2x's, right? So you can write it out like this. 4 times 6 times x times y times y. and then 3 times 6 times y times x times x times x times x times x. And then just eliminate what's the same on the top and bottom because it's all multiplication. So the 6's and 2 of the x's and 1 of the y's, leaving us with 4y on top and 3 and x cubed on the bottom. Okay? So with multiplication, that's all we're doing. Now, I just wanted to talk about that. So if we're doing a division problem, we just get the reciprocal. So instead, z squared is on top, and 6x squared y is on the bottom. Then we can multiply. So we get a negative 1z squared over 6, see, 2 x's, no other x's, so x squared, 1y and 4 y's would give us 5 y's, and 3 z's. Okay, so now we simplify what we can. Well, there's 3 z's on the bottom, so we can get rid of 2 of those z's and get rid of that. So we're left with negative 1, and nothing else can really do anything, can it? So we end up with that. So there's 19, there's 16. Let's jump back and just simplify now. So kind of going all crazy here, but that's all right. So when we're simplifying here, we need to factor. Well, the factors of 6 that add up to 5 would be x plus 3 and x plus 2. So we factor it out and then look for what we can eliminate. Now you can't eliminate just like an x like this. You have to eliminate a whole piece that's being multiplied. So we can eliminate the whole piece, and we're left with x plus 2 over 1, which is just x plus 2. On number 11, same idea, only this one will probably need a little more help. So we're factoring a quadratic. We're going to have to use a box method on this one. So negative 8, 6x squared. Factors of negative 8 and 6, because we multiply them together, so negative 48. Factors of negative 48 that equal negative 47. Well, that one should be pretty easy. Positive 1 and negative 48. Now, 48 is like negative 8 times positive 6. So we can pull out a 6 and an x, 6x. We can pull out a 1, because that would be like times 1, so plus 1. We can pull out an x and a minus 8. Oops, not minus x. So x minus 8, 6x plus 1. So now I can eliminate that, and we're left with 6x plus 1. Now if we're looking at 12, same idea here. So factor that. So box method, got 3x squared, 42. 42 times 3 is going to give me 126. So factors of 126 that add up to 25. This is where it gets tricky. This is where you probably want a calculator handy to help you out. So I'm getting out my calculator, as you can hear probably, and go 126. Well, I know it's 3 and 42, but that's not going to help. So 126 divided by 12 will give me 10.5, not going to work. Divided by 13, not going to work. These are giving me decimals. So I'm just going through 14 and 9. Add those up, that would give me 23, so not quite. So 126 divided by 15 won't work. 126 divided by 16 won't work, because I'm not getting whole numbers, so I need whole numbers. Won't work. 18 and 7. Add those together, yep, that gives me 25. So I've got 18x and 7x. Well, 42 is like 7 times 6, right? And 18 is like 6 times 3. So 3 and an x, 3 and an x. So we're getting 3x, 7 and 7 plus 7, which you can probably see is something we're going to eliminate, right? Times just x plus 6. So those eliminate, we get x plus 6. So, so we're doing the same type of stuff here. So we simplify the top just by factoring it. And we get something. So it would be 2x squared, negative 7. Factors of 2 times negative 7 is negative 14. Factors of negative 14 that add up to negative 13 would be a positive 14 and or a negative 14, positive 1. So negative 14x, positive 1x. So that's like times 1. This is like 2 times negative 7. So 2 and x, 2 and an x. Just an x, just an x, just a 1, and just a minus 7. So we get x minus 7 and 2x plus 1. Now we do the bottom. So, box method one more time. So 2x squared, 10. Factors of 2 and 10 are 20. Factors of 20 that add up to 21 got to be 20 and 1. So 20 is like 2 times 10, like 10 times 1. So pull out a 2x, pull out a plus 1, pull out an x, and a plus 10. So I get x plus 10 and 2x plus 1. So the 2x plus 1s cancel out, and we're left with x minus 7 over x plus 10. Okay, oh, we also needed to define the domain, didn't we? Okay. That's right. So the domain of this new one, x plus 2, is going to be all the numbers, right? Negative infinity to positive infinity for all reals. Same with all these, because they are linear equations, okay? However, something that we'll figure out later on is when we eliminate a piece, it actually causes a hole in your graph. Okay? So, I went and graphed it. So because we're getting answers that are linear, we know linear always keeps going to the right and always keeps going to the left. So it has all reals as a domain. In other words, from negative infinity to infinity. Okay? And all three of those ones have that same domain. The only different problem is when you eliminate a piece, that piece you eliminated, x plus 3, if I set it equal to 0 and solved, I'd get x equals negative 3. At x equals negative 3, look what we've got. We've got a hole in here. It's not defined. Okay? So technically, our domain should actually be negative 8, comma, negative 3, and then union negative 3 to infinity, because it has that hole in there, made from the piece that eliminates. Okay? So if we're looking at this one, that's the piece we eliminated. There's a hole there, and it would be at x equals negative 1/2, because you minus the 1 and then divide by 2. Okay? Now, this is also a rational function, so you've got to wonder about where the asymptotes are, okay, when we're thinking through the domain. And we'll get to that more when we deal more with graphing, so don't worry about it too much. Let's focus on the simplifying. So this one is a difference of squares, because it's really 5x squared minus 2 squared. So that one would simplify as 5x plus 2 times 5x minus 2. That's how we factor it. The bottom one, we could do the box method. Get 5x squared, negative 4. Negative 4 times 5 is negative 20. Factors of negative 20 that are 10. Positive 10 and negative 2. So negative 4 is like negative 2 times positive 2. 10 is like positive 2 times positive 5. So 5 and an x pull out. And 2 and 2 pull out. And x pulls out. And minus 2 pulls out. So 5x minus 2 times x plus 2. So the 5x minus 2's cancel. We're left with 5x plus 2 over x plus 2, which I can't simplify. You may want to say, well, I can cancel that out, but I can't because of the plus. Okay, the only reason I can cancel this and this out is because the whole thing is being multiplied. Okay, number 15 now. So factor this out, factor this out. The bottom's pretty easy. Factors of 9 that add up to 10, x plus 1, x plus 9. The other side, 3x squared, negative 18. 3 times negative 18 is a negative 4, and 2, 54. Factors of negative 54 that add up to positive 25. Well, negative 54 divided by 2 would be negative 27. Negative 27 and positive 2? Nope, positive 27, negative 2, right? So 27x and 2x. Well, 18, or negative 2x. 18 is like negative 2 times 9. 27 is like 3 times 9. So 3x, negative 2, x, and 9. So we get x plus 9 and 3x minus 2. The x plus 9's cancel, giving us 3x minus 2 over x plus 1. Now we know there's a hole right there at negative 9. We know there's an x-intercept where this equals 0, and there's going to be an asymptote where that equals 0. We'll talk more about that later so I'm happy if you can get here. Okay, now we go to these multiplying problems. So we already did number 16. So now let's take a look at number 17. Now we've got some issues, right? Because we're going to have to multiply these as if they're binomials. So x times 2x is 2x squared. X times negative 12, negative 12x. 5 times 2x, positive 10x. 5 times negative 12, negative 60. So we get 2x squared minus 2x minus 60 over I'm probably showing you guys this the wrong way to do, and this will help us understand a little bit better. Then we go and we get x cubed minus 25x minus 6x squared plus 150. Okay, now we would think we're done. There's nothing more we can do with that, but we can actually simplify this better. I don't want to have to go back and simplify it, so here's what we should have done. Can I simplify that? Yeah, if I pull a 2 out, I'd get x minus 6 times x plus 5. I'm just rearranging them a little bit. Okay, let's just kind of smush them together and simplify what we can. X minus 6, well, there's an x minus 6 already, but what about this x squared minus 25? Isn't that x squared minus 5 squared? Well, that's really x plus 5 times x minus 5. We can factor that. So what happens when I factor first and then instead of multiplying first, let's factor anything that can be factored, simplify those, and now look what happens. Those cancel, I'm left with 2 over x minus 5, which I could have simplified those other ones I had to get that. If we graphed them both, they'd be the same thing. So it's always a good idea to start off by factoring what you can. So write 3x squared times x plus 2, because I multiplied those two, but let's not multiply them yet, over x minus 6 times, because it's multiplication, we can kind of treat that fraction bar and just kind of separate them like this. Now, x squared plus 4x plus 4 we can deal with, right? That's x plus 2 times x plus 2. So we can cancel one of those out. We're left with 3x squared over x minus 6 times x plus 2, which I can leave it like that if I really wanted to. If you really wanted to, you could multiply and FOIL it out and get x squared minus 6x plus 2x minus 12, and you would have got 3x squared over x squared minus 4x minus 12. And some of you may say, well, I can cancel the x squareds. You can't. This is being subtracted. If it was x squared times negative 4x minus 12, then yeah, you could have canceled. But you can't when it's just being added. You've got to be able to do the multiplication stuff. So there we go. Okay, so we already did 19, so now 20. So the first step with division is let's change it to multiplication. Times, get the reciprocal, so you just flip it, x minus 1 over x squared minus 2x minus 3. Now I want to simplify these as much as possible. That one's pretty easy, right? Pull a 2 out, we get x minus 2 times x minus 2. We extend that and just think of all of these together. So I know that that's x minus 1. That's as simple as it gets. This one we can simplify, right? We can factor it out. Factors of negative 3 that add up to negative 2. Negative 3 times positive 1. So x minus 3, x plus 1. Okay. Then x squared minus 9, well that's like x squared minus 3 squared. So it would be x plus 3 times x minus 3. Okay. And then we look to see what we can eliminate. Okay. So can we eliminate anything else? Just the x, oh, not that one. The x minus 3's. So we end up with, x minus 1 times x plus 3 over 2 times x, double crap. That should have been x minus 1. Hopefully you guys caught that, because we can eliminate that, can't we? Which would give us x plus 3 times 2 times x plus 1, which I could change that bottom one and multiply the 2 through to get 2x plus 2. And I can also eliminate the parentheses when I only have one. So there's my rational. Now we're going to have to use this when we're graphing them, because everything we eliminate means something. What's left over means something. And we'll use them to help us graph. Okay, so now we take a look at 21. So let's start off. I can pull a 4 out of that and get x minus 6, right, over, I can pull a 6 out of that. The only problem is, to make it multiply, I'm going to put it on the bottom. So we'd make that negative 6 times x minus 6, right? Because 36 would be like negative 6 times negative 6 if I pulled out a negative 6. Okay, so simplified, that shoots up to the top, but let's figure out what it is. Okay, factors of 15 that add up to negative 8. So one of them is positive, one of them is negative. Or they're both negative, or both positive. So negative 3 and negative 5, right, times to make a positive 15, add up to make negative 8. So x minus 3, x minus 5. Now this one's still on the bottom, so it goes down here. Factors of 5 that add up to negative 6. Well, negative 5 and negative 1, right? So x minus 5, x minus 1. So now what do we eliminate? We can eliminate that. We can eliminate that. 4 is really 2 times 2. 6 is really negative 3 times 2. Can eliminate that. So I'm left with 2 times x minus 3 over negative 3 times x minus 1, which I can simplify further and get 2x minus 6 over negative 3x plus 3. And there's our answer. Alright, hopefully not too bad. It's kind of fun when you see all that stuff eliminate and disappear. Alright, now the last problems, find the zeros, determine the multiplicity. So remember, just take what's inside the parentheses, get the opposite. So 1 0 is positive 2. Look at the power with a multiplicity of 4. The other one, opposite of positive 7, so negative 7, with a multiplicity of 3. That's all you got to do. Now, of course, these ones are obviously going to make it a little more tricky, but this one, easy. It's got a 1 there, so x equals positive 2 with a multiplicity of 1, so m of 1. Okay, now these other two. If we set them equal to 0, and we solve for x, we end up with a fraction. So I end up with x equals 3/2 or 1.5. So 3/2 with a multiplicity of 2. And the last one, okay, if I set that one equal to 0, we subtract by 4, so you'd end up with 3x equals negative 4 divided by 3. So x equals negative 4/3, or 1 1/3, or 1.3, with a multiplicity of 3. Okay? So erase that stuff out of the way so you can see what's going on there. Okay, now if we look at 24, So let's set this one equal to 0. But these other two are pretty easy to see, right? X equals a positive 3 and x equals a negative 3, both with a multiplicity of 1. So what about this last one? Well, we subtract 9. X squared equals negative 9. Take the square root. Now we get that negative number, so square root of negative 9 is like the square root of negative 1 times the square root of 9. Square root of 9 is positive or negative 3. So we get a positive 3. Square root of negative 1 is like I. So a positive 3i and a negative 3i. And they both have a multiplicity of 1.